Principle of mathematical induction. In general, induction method is used to verify the given sum of series. As it becomes exceedingly difficult to verify the sum manually, especially when n becomes large. The principle of mathematical induction is stated as: if a proposition or a statement for each positive integer n is such that in step 1 we can prove that this statement is true for n is equal to 1. In step 2, we assume that the statement is true for n is equal to k. In step 3, we prove that if statement was true for n is equal to k, then it is also true for n is equal to k plus 1. Let's apply induction method on following series to verify that their sum is given against the series. Here, let's consider the first example. In example number 1, given statement is that 3 plus 6 plus 9 plus so on continuously up to 3n. Their sum is equal to 3n times n plus 1 over 2. So for step 1, we are going to prove that this statement is true. Step 1, we will show that statement is true for n is equal to 1. So if n was equal to 1, it means that there would be only one term in the series on left hand side. Therefore 3 must be equal to, on the other side, if we replace n by 1, that should become 3 times 1 into 1 plus 1 divided by 2, which gives us 3 equal to 3 times 2 over 2. This means 2 gets cancelled with 2 and 3 is equal to 3. This proves that the statement is true for n is equal to 1. This proves that statement is true for n is equal to 1. Now once we have proved that statement is true for n is equal to 1, for step 2 we are going to assume that this statement is true for n is equal to k. Step 2, we assume that statement is true for n is equal to k. If that is the case, then 3 plus 6 plus 9 plus so on plus 3k must be equal to 3k into, what was the given series? 3k into k plus 1 by 2. 3k into k plus 1 by 2. Without any doubt, we have assumed that this statement is true. So we are not going to question the truth of this. Based upon this assumption, we will prove in step 3 that we will show that statement is true. Statement is true for n is equal to k plus 1. And for that purpose, what we do, we add 3. So let's take a look on the kth term. What was that? 3 times, replace k by k plus 1. This would become 3k plus 3. So adding 3k plus 3 on both sides of equation 1, on both sides of equation 1, what we have is 3 plus 6 plus 9 plus 3k, and if we are adding 3k plus 3 on both sides, this will become plus 3k plus 3 equal to 3k into k plus 1, k plus 1 divided by 2 plus 3 k plus 3. This is what we have added 3k plus 3 on both sides, knowing that the given series is 3k into k plus 1 by 2. So if that is the case, we are going to simplify right hand side, and this will give us 3k into k plus 1 plus 3 we take common, leaving inside k plus 1, and this part is still divided by 2, and now let's take LCM and multiply 2. So this will take 3k into k plus 1 plus 6 k plus 1 divided by 2. And now we can take common is 3 k plus 1 can be taken as common in the numerator. What is left inside is k plus 2 times k plus 2. That's what is left inside. Yeah, and divided by, that is 2. If we can make it like 3k plus 1, everything involving k must be written as k plus 1. So this is equal to k plus 2 can be written as k plus 1 and plus 1. Because we are going to replace k plus 1 by n, and if we still get the same series, this proves that the result is true for n is equal to k plus 1. Replacing k plus 1 by n. What is the series on right? What is the sum on right hand side? That is 3 times n plus 1 over 2, which is same for n is equal to k plus 1. So with induction method, we have proved that statement is true for all values of n. Now we can use this induction method on any other series as well. And let's take a look on the second series, which is 1 square plus 2 square and so on. And let's do the same thing. Given series. So example 2. Given series is 1 square plus 2 square plus 3 square plus n square. This is sum of the squares of natural numbers, and it's otherwise interesting for a math student to remember that this must be n into n plus 1 into 2n plus 1 divided by 6. This is the sum we want to prove, and you can take a look here. This is equal to n into n plus 1 into 2n plus 1 by 6. We will use induction method to prove. That's why you're going to take step 1. Step 1, we will show that we will check the statement for n is equal to 1. It means there was only one term. If that was the case, then in the series on left hand side there should be only one square. That's it. And does it verify the sum? So if we substitute 1 into 1 plus 1 into 2 times 1 plus 1 divided by 6, this will give us 1 square equal to 1 times 2 times 3 divided by 6. And yes, it does verify because we get 1 is equal to 1, which proves that statement is true for n is equal to 1. Now for step 2, we are going to assume that statement is true for n is equal to k. We assume that statement is true for n is equal to k. If that is the case, then 1 square plus 2 square plus 3 square plus so on plus k square must be equal to k times k plus 1 times 2k plus 1 divided by 6. Now remember that we have assumed that this statement is true. We are not going to question about its truth. And for step 3, we are going to prove that if this statement is true for n is equal to k, then this is also true for n is equal to k plus 1. So let's do step 3. We will prove, or we will show, that statement is true for n is equal to k plus 1. And for that purpose, for that trick is that look at the last term, k square. In rough area, replace here by k plus 1. Instead of k, replace it with k plus 1 and then add that on both sides of equation 1. And adding k plus 1 square on both sides of equation 1. If that is the case, this will become 1 square plus 2 square plus 3 square plus so on plus k square and then plus k plus 1 square is equal to k time k plus 1 into 2k plus 1 divided by 6, that was the sum of k terms, plus k plus 1 whole square. Again, like before, we are going to take LCM, and once we take LCM, this will become equal to k time k plus 1 time 2k plus 1 plus 6 into k plus 1 square divided by, that is 6. And if that is the case, then we can take common k plus 1. So we'll take common k plus 1, and what is left inside is k time 2k plus 1 plus 6 time k plus 1. That is left inside, and still we have 6 as the denominator. Alright, now we are going to simplify inside the brackets, and this gives us 2k square plus k plus 6k plus 6 divided by 6, and here we have k plus 1 divided by 6 time 2k square plus 7k plus 6, and we can use AC method for factorization, and we can certainly factorize this like k plus 1 divided by 6 inside 2k square plus 4k plus 3k plus 6, and if we take k plus 1 divided by 6 into, so this is 2k square, we can take 2k common, inside would be k plus 2 plus we can take 3 common, inside would be k plus 2 divided by 6 is already written there. So this is equal to k plus 1 divided by 6 into k plus 2 into 2k plus 3, and here we can rewrite this as k plus 1 by 6 into k plus 2 could be written as k plus 1 plus 1, so that when we replace k plus 1 by n, we can easily write this as well. And 2k plus 3 could be written as 2k plus 2 plus 1, and obviously we can write like this: k plus 1 by 6 time k plus 1 plus 1 into, if we take common 2, this would be k plus 1 plus 1, and now we can replace k plus 1 by n. Replacing k plus 1 by n gives us n by 6 into n plus 1 into 2n plus 1, which is exactly the same sum which we started with, which proves which proves that statement is true for n is equal to k plus 1. Hence statement is true for all values of n, is true for all values of n.